is thick, one is thin. So for sure, transfer is different according to this thickness for this material. So thickness is effect also. So we have different parameters effect for the rate of heat transfer. This is the topic actually for heat transfer focus. So heat is energy being transferred from one object to another. This is all the definition due to the different temperature. This definition we already discussed for the first session of thermodynamic. There are several different types of transfer of heat. What is these types of heat transfer? We have three actually. We have transfer heat by conduction, we have transfer heat by convection, we have transfer heat by radiation. So we have three types: convection, conduction, radiation. Okay, let's see this to study. Conduction is a transfer of heat from molecules to molecules, molecules to molecules. So the contact between molecules is important for the form of conduction heat transfer. We need to be see the molecules is contact together. Okay, so because the concept of transfer of heat here is transfer from one particle to another, one particle to another, one particle to another. So the contact between molecules is important. Just a minute. Okay, as you see here in this figure, actually all forms of heat transfer normally it's happen. It means for any system we can see conduction, convection, radiation. Maybe it's happening with different ways, but we will check this type of this heat transfer in this application. It is conduction. Why? Because the majority or the main heat transfer it's happened by conduction. The other is just neglect, small. So here for this type, for example, we have a candle here is contact with the stick. This stick you touch it with you. So what happened? Actually, you feel hot in your hand here by contact with this stick. Here, contact on molecules, contact with molecules, molecules, contact with molecules. So this conduction. So this one is make it hot for this stick here, and this heat is transferred between molecules contact up to reach to your hand. So this by conduction. But other not happen? No, it's happen, but it's just small. So what's the meaning of convection or radiation? You can understand what happened. Convection actually it is happened due to movement of the flow. Why? Because some of these particles it is going to be contact with a hot surface, so it's to be hot, and the density is changed with the other normal one, which is called one is low density, one is high density. So it's going to move, rotate, recirculate like this. Okay, so what happened? This cold going to instead of the hot, and the hot going to be cold. The cold now is contact with the hot surface, going to be hot, and so on. So this part of air is hot, this part of air is cold. So what happened? After some time, this one going to be here, and this one going to be here. And what happens? Circulation. So if this air it will be hot, it's contact with your hand here, and you're feeling something hot. But convection is very small effect here in regard to the conduction. Radiation also, yes, because the flame, this flame is contact, not contact, it means contact, no, just a C. This hand is see the flame, C. Okay, see the flame with a sum of percentage. So the radiation for this flame is effect in your hand, but just still small effect. So the conduction is the mainly effect on this application. But as you see, radiation it's happened, convection it's happened, but with a small effect. Conductivity. Conductivity, it is how efficiently substance transfer heat between molecules to be this good conductor or not good conductor. So it depends, this conductivity depends on the material and the bond between material. If this material it's have strongly bonded, so it's good contact, so it's high conductivity. But if it is have low bond or maybe not bonded, same like gases, so it's low conductivity. Liquid is in between solid and the gas. Okay, so conductivity depends on how molecules are structurally bonded together. Okay, so it's depend on the state of matter. This conductivity. But we have another thing, and let's see difference between two things, very important and tricky in the exam for theoretical: conductivity and the heat capacity. Okay, conductivity and the specific heat capacity, both it is a properties in the material. So we have tables, we have value for conductivity, we have value for specific heat capacity. So what is different? Both related for heat. Conductivity, it just told you this one is high conductive or no. This high conductive, this low conductive, this higher than this one, and so on. Conductive. Okay, it means heat transfer is can transfer good. That's it. But we will see another one, maybe next slides. This table related for conductivity. As you see, some tables here, sulfur 427 and going one by one up to water in the middle. Air, it is low conductive, so we use it as insulator material. But let's see the other one, specific heat capacity. Definition of a specific heat capacity we will study before, which is related to C. You remember specific heat capacity, CV and CV. Specific heat capacity is general amount of heat needed to raise the temperature of 1 gram of a substance by 1 degree C. Property for the material? Yes. What is different between this one and the thermal conductivity? Difference, this one is depend on the rate of response for the material. Response, it's not good conductive or bad conductive. No, not describe that. It is the response for material is quick or slowly. What's meaning? I bring two material. Both is good conductor. Both is good conductor, like copper and aluminum, like iron and aluminum, whatever. And I put both in the cooker. We will see aluminum is going to be faster to be heat, correct? And also, if I removed, I released from this cooker, what happened? You're going to cool down quickly also. It means the response of heat. Response of heat. If the response of heat, cool or heat quickly, this low specific heat. But if this response slowly, it's going to be hot, take time, and cool down, take time. So this one, high specific heat. So specific heat is related to the response of the material. It's going to be hot and cold. Take time or no? Quickly or slowly? Okay. This material, some also examples. For example, here for a specific heat, for water is 1, for example, for air 0.24, for granite 0.19. Okay, we have one example between all materials have good conductor, but according to specific heat is good response, fast response, or slow response. Convection. Convection heat transfer is transfer of heat related to movement. Related to what? Movement. As you see, the contact here between the burner here with the glass, the pan. See, this hot. What happens? This hot going to be up, which is the cold part. So I'm going to move. This movement. So the mass movement of a fluid or a gas like water and air or whatever. So this one going hot, going up. This air is going. It is already cold, so it will be slightly hot with the water coming from down to up and so on. Okay, so warm part of the fluid raises and the cold part sinks. Here also for the atmosphere, the warm air for the atmosphere going up, the cold air is going down, and so on. Latent heat, we studied this one before, but just we're going again to remember. Latent heat and sensible heat. What's different between latent heat and sensible heat? Latent heat and sensible heat, difference between these two. Latent heat is related to phase change. Sensible heat, it's related to temperature rise. So if I add heat to body, this heat is going to one of two, not two together. It's not happen together, one of two. It's going to latent heat or going to sensible heat. If going to sensible heat, it's just going to temperature rise. That's it. Temperature increase from temperature to another. But for latent heat, is going to change phase. So the temperature is still the same, not a change, but just I add this heat to change phase from solid to liquid, from liquid to gas. That's it. Okay. So the latent heat definition is energy required to change matter from one state to other. That's it. There's different types for that, for latent heat. Here, the latent heat, for example, from the solid to liquid, this melting process. From liquid to vapor, this evaporation process. In opposite, for vapor to liquid, this condensation. From liquid to ice, this freezing. Sometimes we're going to just quick. From solid to gas, this sublimation, and from vapor to solid is deposition. Okay. The latent heat for melting is called latent heat fusion, and latent heat for evaporation is LV, latent heat of evaporation. See the values here. The latent heat of fusion 3C5, this is the amount of heat, but here latent heat of vaporization 2500, which is difference. So it is easy to change it from solid to liquid, but it's so difficult to change it from liquid to gas. Okay. Each times latent heat required, for example, something like this. What is the latent heat for total? Just direct summation between fusion and vaporization, this sublimation. Okay. Let's see one question here. Why does metal feel colder than wood if they are both at the same temperature, both contact with your hand, but one you feel cooler than the other? As you see, the answer is very easy. Metal is conductor, good material, good conductivity, but wood is not good conductivity. So it's like insulator material. So the metal here conducts the heat from your hand, correct? The metal is conducts the heat from your hand. So what happened for your hand? It's feel cooler, but wood doesn't make anything for that. So it's not feel anything with wood. But when you see this one is cooler than this one, so it's sometimes you see this one is feel like warmer than this one. Okay. What is the third type of the heat transfer? We study conduction, we study convection. Now the third type, radiation. How does heat energy get from the sun to the earth? So there is no space, no need for media. Yes, this radiation is not required any media to move for the heat. No need for particles transfer, no need for that. No need by movement for convection, conduction, by contact molecules, no need for anything for that. This radiation. So radiation travels in straight lines. True or false?
True.
False.
True.
False.
This travels in straight line. Radiation can travel through a vacuum.
True.
Yes. Radiation requires particles to travel.
False.
False. Radiation travel at the speed of light.
True.
False.
True.
The Earth, it's almost like speed of light. Let's see this question. Read carefully, and you're going to solve. You have 4 containers. Were filled with warm water. Which container will be warmest?
Dull black.
Dull black.
The water will be warmest. Which one?
Dull black.
Dull black.
All the same.
All the same? No, for sure. The color is effective for that. Color is very important for radiation.
Yes.
Shiny black.
Black
Shiny
body
black.
radiate.
black, the darkest
Color.
color.
This is the mainly control for everything for radiation. So 4 containers here is filled with water. It means the warm water inside the containers, the source of heat inside the containers. So which container will be warmest to water after 10 minutes? Keep it the same warmest inside. So it's not release any heat outside. Which one? The warmest one is shiny metal. Shiny metal is the warmest one. Why? Because it reflects all heat. Whatever the heat inside is going to be reflected inside, and whatever the heat coming from outside is reflected outside and coming to inside again. So this is due to radiation of heat, reflection of the heat all the time for shiny metal. Correct? But for dull black is emit energy. Okay, so it will be coolest one. So because it's emit this black body, like black body, dull black. Okay. Read the second one. Still the question, which one has the warmest water?
Dull black.
Dull black for the first answer.
Yeah.
He asked for what? The source of heat now, it is not inside. The source of heat, it is outside. I put the 4 element and
Dull metal.
equal distance from the heater. It means the source of heat is it is outside the container. But according to the source of heat outside the container, which one it is have the warmest water?
Dull black.
Dull metal because
Dull black. Dull black is the warmest one. Why? Because the absorb heat. This dull black absorb. It is emit everything and absorb everything. But shiny metal is still reflect everything. So if reflect, so this is a burst for absorption because it reflect everything. Okay. Why does hot air raise and cold air sink?
The density of hot air is less.
Which one?
The hot air
Yes,
rises.
it depends on density. Clear. Yes. Cold air is more dense. Cold air is more dense than warm air. So the cold air falls through the warm air. Cold air
Like hot
going
air
down
balloon.
and warm air going up. Why are boilers placed beneath hot water tanks in people's homes?
Conduction is the best source.
Again,
Conduction is the best source of heat transfer.
conduction. Conduction for what here? Hot water tanks. What happens for hot water tanks? Is going to be hot, and circulation of movement. And what happened also after increasing the airspace between the water tank and the airspace, just like clearance area, it will be hot, increasing. This air is going to be increase. What happened for the pressure? Increase. Yes.
Yeah.
So hot water raises. So when the boiler heats the water and hot water raises, the water tank is filled with hot water. So we need like safety, correct?
Correct.
Why are houses painted white in hot countries like Doha?
Absorbs less heat.
Absorbs less.
Yes, it is dependent for radiation. White reflects heat radiation and it keeps the house cooler. Which of the following is not method of heat transfer?
Insulation.
Yes, exactly. Transmission of heat by molecular collision is?
Conduction.
Conduction. So heat is transferred now by conclusion by what? 3 methods. Conduction, mainly in solids. Convection, mainly for fluid, whatever liquid or gases. Radiation, mainly for space. Correct? So by conclusion here, the method used for heat transfer is usually one that's the most efficient. This is what I tell you for the example of the candle. Okay. Conduction and convection involve particles. Radiation involve electromagnetic waves. What is the factor affected for heat transfer? I tell you some notes for that during the example I've started for difference between thermodynamic and why we study heat transfer. So what is the factor affected for heat transfer?
Container.
Area.
Area, temperature difference.
Yeah,
If you
material.
don't have temperature difference between the system you study and surrounding or between two objects, there is no heat transfer happen. So temperature difference, thickness, area. Okay, so this some factors and type of material depend for or affect for example, can appear for thermal conductivity for the material. It can appear for heat transfer coefficient for convection, some parameter related to radiation also, mainly for example something related for colors depend on what how many the percentage for the absorption for this one. Okay, let's see this one in detail for the equation requested. Here in the case for HVAC, we don't have many equations, but it is important numerically is coming for some specific equations, not far equations for for here for heat transfer. We have some example for convection, conduction, radiation. I bring two or one example for each one. Also, we have one regular questions coming in the exam a lot is related for heat transfer, the effect of latent heat, the main equation for Q reject, like Q equal mc v delta T. So we will study here for numerical, it's not huge, and we will focus for what is example or problem question coming before. But for theoretical, it's have many questions as you see here related for heat transfer. Let's see. The first equation requested for conduction is Q by delta T, which is heat with time. This heat transfer, Q dot, okay, equal minus K A delta T, delta T over X. This is what we discussed already. K is thermal conductivity, A is area, X is thickness, delta T, which is referred to difference temperature. Okay. Delta T over X have a famous name and coming for the exam a lot. It's called temperature gradient. Temperature gradient. You remember velocity gradient and viscosity? This is something like this, equivalent like that. Okay. Also, before I forget, this heat is called heat transfer. We have another name used a lot. It's called heat flux. What is heat flux? Heat flux is Q dot, this heat transfer, per unit area. So the equation, it will be like K delta T by X direct like this. Okay, this what is this? Heat flux. So if you don't have or given area in the question, no problem. It's going to calculate heat flux. And sometimes given heat flux like this, heat flux equal blah, blah, blah. So don't forget this name. Heat flux is the heat transfer per unit area. Delta Q by delta T is this rate of heat. K is thermal conductivity. A is area. Delta T is change in temperature. X is thickness. Delta T by X is have an important name, heat temperature gradient. Temperature gradient. And this temperature gradient delta T by X, it will be negative. So this is the reason for both negative here to be negative, negative equal to positive. Okay. Temperature gradient. Okay. I tell you a lot. Okay. This is the same heat energy can transfer for convection when I have a significant in temperature difference between two parts of fluid. So because it's related between fluid and the other, between fluid, gas and liquid, and so on. Okay, and it's coming due to the movement happen for this between two fluids. The equation for conduction. So now we studied the equation for conduction, which is delta Q by delta T, Q dot is equal to K A delta T by X. Okay, all equation for heat transfer is saved. Okay, should be saved, please. Try to memorize because it's not given in the exam, by the way, because it's not difficult actually. For convection, Q dot here equal HA delta T. So we don't have effect for the thickness here for convection, just going to be movement between the two fluid. So different temperature is important, area is important. What is H? This H is convection coefficient. Convection coefficient. As you see here, the H is watt per meter square Kelvin, and for the other one, Ka delta T by X, you will see the K here, unit is watt per meter Kelvin. So the difference between K and H, also in units, this watt per meter Kelvin and this watt per meter square Kelvin. Okay, why I write it here in details like this? Because we have a question for units related for K or H. Delta T here is related to Ts minus T infinity. Normally Ts is referred to all the time to surface, and infinity is referred to the other gas or fluid movement above the other fluid. Okay, it's called T infinity, which is a movement one. Radiation. Radiation here, Q dot is equal to area also, epsilon sigma T to power 4. Okay, area A, epsilon is called emissivity, and for black body is equal to 1, which is the maximum. Other colors have a table for emissivity. Sigma is a constant, should be saved also, 5.67 10 to the power negative 8, 5, 6, 7, 8. Okay, just remember like this, 5, 6, 7, 8. 5.67 times 10 negative 8, this Stephen's constant. T is a temperature for the surface required. T is a temperature. Be careful, especially for this equation. T here must be Kelvin. T here must be Kelvin. You ask me for the previous, it's not important because this delta T, whatever temperature or Kelvin, okay, Kelvin or Celsius, so gives the same answer at the end because this delta T for both equation here, conductivity and convection, conduction and convection. Okay. Actually, this is the mainly equation required for heat transfer. It's not big, easy, but memorize, please. Any question for the equation here? Okay. Metals are good conductors of heat. Why?
Their atoms collide frequently.
Again?
C.
Collide frequently.
Because it's contain free electron. Contain free electron. We have here some notes for why metal are good conductors. Actually, for two reasons. The close packing of the metal ions in the lattice contact. Delocalized electrons can carry electric kinetic energy through the lattice. One to another, one to another. Delocalization for these electrons carry kinetic energy, and the heat is coming due to kinetic energy. Heat is shown to be closely related to hello.
Temperature.
أول أجري
Energy.
Momentum.
Energy. This heat is related to mainly for temperature. It's coming due to temperature difference. Body A kept its contact with body B. Heat will flow from A to B. So what is the correct answer? A to B.
B.
A. B. B. Temperature of A is greater than that of B.
Mainly temperature. Mainly temperature. Heat can transfer from one to another due to temperature difference. So B is correct answer. Cork is a good insulator. Why?
Sporous.
It's porous. Exactly.
Yeah.
So let's see this one here for the cork. This some type of material used as insulator material because it's have a bad conductor, so it's used as a insulators. Mainly all this have objects is need to have airs inside, air trapped inside. So metals here like cork, which is have like something like pores, it's have many holes, air inside. Fiberglass, styrofoam, also black hole, also what else? Rubber. All this is bad conductor material. So this is due to a lot of air trapped in them. This used as insulator material. This is also to be confirmed for that, like cork, wood, styrofoam, rubber. All this used as insulator material. Which one of the following can't be unit of thermal conductivity? Which thermal conductivity? Thermal conductivity is what? E.
First, A watt per meter Kelvin, right?
Watt per meter square Kelvin. So what is watt per meter square Kelvin? Rated for what?
H.
H, exactly. Yes, this is for H, not for K. Which one have least value of thermal conductivity?
Air.
Air is insulator.
Excuse me, doctor. The question 6 for the units of K and H.
Yes.
Watt per meter squared Kelvin is
H, thermal conductivity. Convection coefficient. This one for convection coefficient. Wait. Why I do like this?
okay, doctor. Okay, thank you.
H, this one for convection coefficient, but K it will be watt per meter Kelvin.
Yeah.
Okay.
It's for convection. Okay, thank you, doctor.
Welcome. There's some metals here to just describe thermal conductivity. As you see here is a lower one, almost lower one. Diamond it's have a higher one. Which one is highest?
Copper.
Again?
Copper.
Copper.
Copper. Copper. The answer for this question on internet material not correct. Okay, copper is correct. Which metal heat up fastest? Copper, silver, or lead? Aluminium, copper, silver, lead.
Copper.
You to ask me for what? You can compare.
Silver.
What?
Heats up fastest.
Yes. Yeah. You need what to can take a decision which one is heat up.
Specific heat.
Specific heat, not thermal conductivity here. Specific heat. So according to the value for specific heat, you need heat up fastest. So it's low or high specific heat required?
Low.
Low. For quick, fastest, low specific heat. Let's see. This is specific heat for different material here. This one for aluminum, copper, silver, and lead. So which one is the correct answer?
Lead.
Lead, exactly. Heat conduction doesn't occur. Tricky question this.
E.
E.
If temperature difference.
Such idea for heat transfer.
C.
Exactly.
The
If
bodies are
there's
kept
no
in vacuum.
difference between two bodies. steady and unsteady. It's same like steady and unsteady for velocity. Here's in temperature. We have many things similar, like similar this one, similar like this, similar this one, like this, like similar like velocity gradient, temperature gradient. It's okay. Here steady and unsteady also. If the temperature constant with time, temperature constant with time, this is steady state. If the temperature vary with time, this is unsteady state. There is no variations of rate of heat transfer, the steady state. Change in internal energy with time interval, 0. But for unsteady state, no, not 0. Okay? Similar like for velocity, steady and unsteady. Heat transferred by conduction, convection, radiation. It means the three, it's happened, and you can see no one is, it is a measure for the heat transfer for this application. 3, it is happen.
Melting of ice.
Which one?
Condensation.
Melting of ice.
Melting of ice.
E, condensation of steam. Because
Condensation.
triple point.
Any more answer?
Yeah, solid, liquid, and gases though. I think melting of ice.
No melting of ice. The middle one, it's happened 3, conduction, convection, radiation. It's happened due to the process for that boiler furnace. Boiler furnace, it's have a flame. This flame is contact with gases, exhaust gases, tubes, water. So we have fluids, contact between fluids, movement between fluids, convection. Flame sees others, so radiation. Liquid, the tube itself, conduction from the surface to the surface, from the outer to inner, conduction. All this happen due which one, which applications can include all this for these types? Boiler furnace.
But in boiler, how can you explain how the radiation occurs? Because radiation does not require any medium, right?
No, we have.
No, but there is no vacuum present. Correct?
Inside the boiler, we have flame, correct? This flame is contact with the tubes. Not contact, it means contact. It's C tube. So this tube sees the flame, the radiation coming from the radiation coming from the flame, according to the percentage for how to see this flame.
But
Mainly
that heat will transfer due to convection, right? Because there is air in between, which will get heated and it will transfer the heat to the tubes.
both.
Okay.
Not only by heated air, both.
Okay, so it is not mandatory that there should always be vacuum.
Area is vacuum. It will heat up for this tube.
Correct. If there was vacuum, then it would be only radiation, correct?
Again?
If there was vacuum, then it would be only radiation, not
Yes.
convection.
But actually we have a convection due to the exhaust gases coming from also from the flame. Also convection happen due to contact between the hot gases and the surface of the tube, the liquid inside the water and the surface of the tube. This is due to convection because this fluid is movement fluid. But the tube itself is conduction, solid. Okay.
Yeah.
Transient heat flow occurs in something it can't control for that.
D.
Yes, heating and cold for building due to sun. You can't control the sun. Molecular transmission of heat is smallest in case of
Gases.
Gases.
yes, excellent. Essential requirement for transfer of heat from one body to another is
Temperature difference.
Temperature difference.
clear, easy. Force Celsius equivalent to what? Just going to calculator, convert, that's it. It's not difficult. When you use this as a converter, we will see the answer is 104 Fahrenheit. Yeah, anyone ask me, is this question coming like this in the exam? Yes, yes. but not more. One question more. That's enough. Temperature inside furnace is generally measured by
Pyrometer. Pyrometer.
optical barometer. Yes, exactly. Read
What
this
is optical
question, please.
parameter?
Read this question to solve it here. This one apply for the conduction. So I write the equation here. I need from you to solve this question. Q dot is equal K A delta T by X. Solve it, please. I give you 2 minutes to solve. 1 minute. 1 minute is enough. Half minute to read. 1 minute for solve. I wait you. Anyone get it? No one get it?
Hundred.
Answer?
8,000.
Which one?
8,000.
1,000? Which is 1,000? This one or this one? 8,000?
8,000.
Let's see. K is 40. Area?
Heat flux.
Heat flux.
It's
So
flux. Yeah.
consider as a 1.
1.
Delta T. 10
10.
slices. X.
0.005.
That's it. So the answer is
8,000.
8,000. And this equation here. Let's go to this next problem. Solve it, please. Same problem we can solve with the same equation here. Q dot A K delta T by X. Get answer?
630.
Again?
630.
Negative. Negative.
Negative.
Value?
Yeah. Correct.
Yes, exactly. K here is given 0.9. Area is this area, which is 3 meter times 5 meter. This area is heat transfer area. Delta T it's 16 and 2. X is the thickness, so we can substitute direct for this problem like this. Okay. Here, I discuss with you another thing is also coming for theoretical part. It's called thermal resistance. Normally, we going to change heat transfer to shape of circuit, circuit for the electric. We change it to be easy for solving. We transfer mechanical to electrical to be easy, okay? So what happened? This resistance like this, okay? Actually, the problem here, we can define this one like this. Is like this one, resistance, which is the building itself is resistance. This volt is 16, this volt is 2. So we present a volt, which is here is represented as a temperature, and we have resistance, and we have flow, which is referred to the Q dot. So what is resistance here? Let's see. Resistance, as we know the equation, Q, not Q, I equal VR or V equal IR.
V by I equals R. So
Again,
V by I equals R.
I equal R.
V equal to IR.
Okay, so R here is equal V over I, correct? I represent what? Q. V represent what? Delta T. We need the general equations like this to conclude what is R. Let's see, Q equal K A delta T over X. I need delta T over Q, so I will put this in other side and put Q here, correct? Delta T by Q equal X up, down is Ka, correct or not?
Yeah.
So what is this? R, refer to R. What's meaning? Thermal resistance. So the thermal resistance is L or X, this refer to X, divided by Ka. Thickness divided by Ka. This what? Thermal resistance. You aware now what is thermal resistance?
Yeah.
Okay. Pipes are insulated so that
D.
D. Heat loss minimized.
D.
D. Heat loss from the surface is minimized. All heat transfer process
B.
temperature difference, concept of heat. Steady state heat transfer occurs when
It flows uniform. B.
you forget the session of velocity. Steady state.
B.
Steady state depend on
Dependent on
time. Depend on time. So steady state, the heat is independent of time. Thermal diffusivity is
B.
which one?
Dimensionless.
Thermal diffusivity? No, not dimensionless.
A B.
It's a property for the material.
B.
So
B.
what is this one? What is this parameter?
Porous.
Thermal diffusivity, it's something equivalent to kinematic viscosity, but kinematic viscosity for flow, for velocity, and so on. Thermal conductivity here, thermal diffusivity here in the heat transfer. Okay, so what is thermal diffusivity? Thermal diffusivity here, this a thermal response of a material to change in temperature, and is equal to this one. Thermal diffusivity is equal to K divided by rho Cb. What is K? Thermal conductivity. What is Cb and rho? Rho is density, Cb is heat capacity. If you remember, kinematic viscosity is viscosity divided by also rho, something equivalent. K, this here, mu. This rho is rho, but we added Cb to obtain equivalent units. So what is unit for this one? Meter square per second. What is unit for thermal diffusivity? meter square also per second. We have many things for similarity between these two. Okay. The unit of thermal diffusivity is
meter square per hour. B.
is meter square per second. So the correct answer here is what?
B.
B, meter square per hour. Homogeneous material, just three definition: homogeneous, isotropic, anisotropic. Homogeneous material is the material of uniform composition throughout that can't be mechanically separated into different materials. This is homogeneous. What is example for homogeneous material? Like plastics, ceramics, glass, metals. Almost. Could you please close mic, please? Close mic. Isotropic material. Isotropic material, it means here a material having identical values of property in all directions. Okay? Like what? This like, for example, glass and liquid. But for anisotropic materials, its properties such as Young's modulus change with direction along the object. This like wood and composites. This is general difference between homogeneous and isotropic. Let's see one question for that. Non-isotropic conductivity is exhibited in case of wood. For glass wool, the thermal conductivity varies from sample to sample because variations in
Porosity.
Porosity.
All,
only porosity.
All of the above.
All of them.
Yes, all of them. We have many numbers used for heat transfer. Numbers like Redo's number, like Mach number in fluid mechanics. Here in heat transfer also we have many numbers. Okay, but I just focus here for two important numbers. It's can coming for ask for this one theoretical, and we see this question theoretical in the exam for exam 5 we have. So Nusselt number is equal to convection heat transfer to radiation heat transfer. It means the ratio between convection and the conduction. Convection and conduction. So Nusselt number is equal to H by K. But these two is different units. So we add here multiply by L to be equivalent unit. Because as you know, number, it means dimensionless. Nusselt number or any number, it's dimensionless. So HL over K. H and the K is have a different length, which is one is watt per meter square Kelvin and the other one is watt per meter Kelvin. So we have its missing length. So we multiply H by L divided by K to be dimensionless. This Nusselt number, convection and conduction ratios. What is L? This characteristic length. Other important number is Prandtl number. Prandtl number is coming to bring something from heat transfer and something from fluid. What is this two? Thermal diffusivity and kinematic viscosity. Both is meter square per second, so it's the same equivalent units. So it's just ratio between these two is going to be Prandtl number, which is dimensionless. Viscous diffusion rate by thermal diffusion rate. Viscous diffusion rate by thermal diffusion rate. This the thermal diffusivity and this kinematic viscosity. These are the two important numbers for heat transfer. By this slide, I finished the part for heat transfer. Let's go to the HVAC part. You need break? Need break?
Yes.
Okay. Let's
Probably
take.
yes.
Okay, take break. Hi. Sorry. Before I start, for next session, it will not be tomorrow. It will be Monday for regular time, okay? Hello?
Yep. Okay, doctor.
Okay, confirm for all.
Yeah, okay.
Okay.
Yeah, no session tomorrow. It will be for regular time, Monday. Just I finished the discussion for this. HVAC. For this part, it is easy part. Just here for this point, we will focus for psychometry. This is a mainly part need for more information. Many question coming for the stoichiometric chart. Let's see first. HVAC, this is abbreviation for heating, ventilation, and air conditioning. HVAC coming for what? For control temperature, control humidity, air quality, air distribution, and also noise control. We have two main types for HVAC or air conditioning AC. What is this two main type? DX system and the chilled water system. DX system and chilled water system. To be easy for you, almost all types of air conditioning we can classify it under one of these two, DX or chilled, whatever the name for this type. Before we can classify, once you see the name, this it is blah blah chilled water, this DX. Now is no. We have a overlap. Like for example, before air handling unit is used normally for chilled water. Now we can use it for both DX or chilled water. Before we can use ducted system for something. No, we can use it for both. So for any system now, we can use it for this type or this type. So how can decide this DX system or chilled water system? By easy thing. Just to check the system. If the system or this cycle, the air is contact direct with the refrigerant, so this DX system, direct expansion. But if the air is not contact with the refrigerant direct and the contact with intermediate media, and this intermediate media normally is water, so this is chilled system. Chilled system, it is two cycle by easy or simplified definition, easy two cycle for refrigeration. One between the refrigerant and the water, and one between water and air. DX refrigerant to air direct. So any system you can see, check this refrigerant contact with air, or this refrigerant contact with water, and the water is contact with air. Clear? According to this description, we can classify this system DX or this system chilled water. Psychometric chart. Here in psychometric chart, I bring two figures, or one is simple, other one is more advanced. Let's see the first one, easy one. Should be know each line refer to what? Question ask for the line. Here, I start by dry bulb. Dry bulb is represented here in the x-axis, which is referred to vertical line, or vertical line here referred to dry bulb temperature. So what's next? Horizontal line for y-axis. Horizontal line here, it's referred to humidity ratio, okay, or moisture content. both the same, humidity ratio or moisture content. Next, curved line. The curved line is referred to relative humidity, and this is the maximum one, which is referred to 100% relative humidity. Relative humidity. What is next? The next is inclined line. Inclined line refers to what? Inclined line referred to enthalpy and also wet bulb. Both in the same line? No. Actually, this angle of inclination is referred to enthalpy, and also have another line referred to with bulb temperature, also in almost the same angle, same slope. But how can we define between enthalpy and wet bulb? And we can see this one, it's referred to wet bulb or referred to enthalpy. This is the only thing difficult in the curve. Actually, for enthalpy, this curved line here, if it is already drawn in the figure, normally wet bulb not presented. I tell you why. Because almost the line is almost parallel. So we can't to make different separation between these two. But this line is referred to 60, correct? 60 what? 60 energy. Kilojoule per kilogram. So this energy here, 60. The line is ended here. Okay. Here, 40. Here, 80. Okay. Take this point and go down. If the value here for the inclined line is the same value for vertical line, so this is not enthalpy. If not, is different, so this is enthalpy. So here, for example, this is around 14, this 60. So this is not referred to wet bulb. This refers to enthalpy. Let's check the other thing. Here, definition for relative humidity, which is referred to the curved line, defined as the ratio of mole fraction of vapor in the mixture to the mole fraction of vapor in saturated mixture at the same temperature and pressure. Let's see the exact stoichiometric chart. This inclined line, this one specific volume, it's not required. Not asked for this in the exam. What is asked? Dry bulb, this point here, we study this point actually. Dry bulb, red line, vertical. Moisture content, horizontal. Percentage saturation or relative humidity, curved. And the inclined line. Here, in this curve, you see this inclined line. You tell me this is the same previous. It is enthalpy. Let's check. Where is the line for 100% relative humidity? This line, relative humidity 100%, it's the last one. Okay, I check this value here, which is 5. Take this 5 and go down. What we will see? I will see the same value 5 here, the same value 5 here. So the inclined line here 5 is referred to wet bulb, not enthalpy. Let's see 0. This 0. Let's go vertical like this, 0. So here inclined line refers to wet bulb temperature. So where is enthalpies? We can't neglect from the curve. No, this is one of the major thing in the curve. This represents for energy of the point. So it's very important. No curve psychrometric chart without enthalpy. So how to present enthalpy? We present enthalpy by external scale. This scale, this one from this side here, as you see here, all this up to above, and the other scale, this one here, this side, and this side. What is this scale? This scale starts from -10 up to the maximum here. To bring the value for enthalpy here, just we bring a ruler. Just bring what? Ruler like this. And this ruler here, I put it the edge of the ruler on the point required to the request energy here. Put the edge of the ruler here and rotate this ruler. Rotate this ruler up to match between value in this scale with value on the same scale but on another side. Match between these two. Match the value between these two. So I going rotate up and down here, move clockwise and anti-clockwise up to reach here, for example, match between 39 and 39 kilojoule per kilogram. So this is the value for enthalpy for this point. Clear now? Any question? Going to